Okay, we shall begin. So we're continuing our lecture on object-oriented programming in R. And so last time we talked about S3, and today we'll talk about S4. So S4 is similar to S3, but it adds some formality and rigor. Again, with S3 and with S4, you have methods belonging to functions, not classes. The key difference between S3 and S4 is that classes will have formal definitions which describe their fields and inheritance structures. And method dispatch can be based on multiple arguments to a generic function, not just one. And we use a special operator, the @ sign, for extracting slots or fields from an S4 object. Okay. So whereas before with S3 you could just willy-nilly just say, the class on this thing I'm going to change to tic-tac-toe class, or I'm going to change the class on this thing to a LM class, or change it to a data frame class. With S4 you can't do that anymore. Okay, and when you create a class, you define it in a formal manner. Okay, the S4 related code is stored in this methods package, and it's always available when you're using R, but then if you do things in batch mode, it might not be, and so it's usually a good idea to run library methods. Okay. As far as it comes to recognizing S4 objects or generics, there is a command that just says, is it S4? You say is S4 and it will say true. If you call structure str on the object, it will say it is a formal object. Okay. And of course, if you load up Hadley's package prior, their object type, the O-type function, will return S4 if it's an S4 object. Okay. In the base stats package in R, there aren't any S4 objects. All of the base stats objects that exist are going to be S3 types, but we can build S4, and it exists in the stats package, stats4 package, whenever you do for maximum likelihood estimation. So this is just this example only serves to show that S4 objects exist. Okay. And so, we can load up library prior, library stats, and, we define a function which is going to kind of calculate the log likelihood of a set of data based on the Poisson distribution. Okay? And so, I don't know if you guys are familiar with maximum likelihood estimation, but you want to find a way to calculate the likelihood of a set of data. And so normally you would find, using the density function, you would find the probability of getting that particular value, and then for the likelihood, you would multiply that product altogether, right? You would multiply assuming everything's drawn IID, you would say, what's the probability of getting point A? What's the probability of getting point B? What's the probability of getting point C? You multiply those things together. Okay? But then if you have a whole bunch, that probability can get to be very, very, very close to 0, and you could run into what's called an underflow error, because the computer might not be able to keep track of these values that are so close to 0. So instead we do this, take the log, and now instead of getting a tiny number, you get a negative number, and you can add a whole bunch of negative numbers together, and that's what we're doing here. Okay, and so anyway, we're gonna say find the maximum likelihood estimation, giving it this kind of likelihood function, and we're gonna say, okay, using this parameter. Okay, anyway, we store the output of the MLE function. So MLE is a function from stats4 package, We store the output of that thing into fit, and if we ask is fit an S4 object, it's going to say true. We can ask OType, which is a function from prior. We can say, what is the object type of fit, and it will say it's an S4 object type. No big deal. We have methods, okay, or we have functions. And so there's a function called nObservations, or maybe I'll just say knobs, okay? nObservations, this is an S4 generic. So you guys remember generic functions from S3? What are generics? Maybe we don't remember. So print is a generic function, and a generic function would be a function that can behave differently based on the type of object you give it. Okay? And with a generic function, you're going to find this thing that says use method. And so when you run print, it's going to look at the object you give it, and it's going to say, oh, you've given me an object of class factor. So now I'm going to look for the factor method associated with print. So we're going to go to print.factor and use that to print out the object. Or we could say, print this thing, and it'll be like, oh, this is an ANOVA object. So I'm going to look up print.ANOVA or print.summary or something for that particular class. We have similar type of concept for S4, except they're called S4 generics. Okay, and so nObservations is an S4 generic, and we can say, is it S4? And it's going to say true. And let me just kind of demonstrate this. So fit is an S4. nObservations is a function. It says standard generic. This is how we say S4 objects are generic functions. And we can say, is nObservations being a function, is that an S4 function? It is. If we ask prior the f-type function, what is the f-type function type of nObservations? It's going to say it's an S4 and that it's a generic function. Okay. So when I call nObservations on a fit object, on the object fit, okay, it's going to recognize that fit is a MLE object. Okay, it's going to say fit is an MLE object, so when it runs nObservations on fit, it's actually running, what it's running is it's actually running the MLE method for nObservations. Okay, and so with S4, we don't define things, we don't just say nObservations.mle or nObservations dot, the other type of thing that we're looking at, okay? We don't use that kind of syntax here. We actually have to formally define in here that this is going to be a method for nObservations. And so to figure out which method is being used, I can say, okay, so when I run nObservations fit, so nObservations being a generic function is going to look at this fit object. It's going to say fit is MLE, therefore I have to run the appropriate method for nObservations, okay? And so here there's a function that says method from call, okay? And so method from call says, what is the method being run when you run this command, okay? And so method from call is going to tell me, like, okay, what is the method being run? When we run it, it's going to be the nObservations method for the class MLE, right? Because fit is a MLE class object. Okay, and so it looks a little bit funny, but what it says, oh, this is a method definition, okay, and it's a function, and it's running, and this is the function. It's saying if number of observations in slot name, otherwise do this or something like that, okay, and we can see this is for MLE objects. Okay, so this is the function for the generic. So this is the method for MLE objects when it's being called for number of observations. Okay, whereas knobs itself, number of observations, is a generic function, and we can see this thing, standard generic n observations, so that when we run n observations, it's going to look at what kind of object is this? Oh, it's a fit object. Okay. I mean, not a fit object, it's an MLE object. Okay. So now we have to run this thing. Okay. And so we can store this and say MLE underscore NOBS and say this is the method for number of observations for method, okay, for the MLE class. We can say is this method S4 MLE underscore number of observations? Yes. And the function type for MLE underscore number of observations, yep, it's an S4 object, and it is a method versus generic, where if we say, well, you know, what was the function type? Oops. For number of observations, it's a generic function. Okay. So generics is the name, and where it's going to say, okay, I'm going to now look at the class of this thing and look up the appropriate method for this class. Is that okay with everybody?
So you don't have to specify like you might with in S3 where you do like print dot ANOVA, for example.
So in S3, whenever you call print, print has, you know, use method, right? It has the use method thing, and so what it's going to do is print in S3, when you call print, it's going to say, oh, what kind of object did you give me? Oh, you gave me an ANOVA object. Now I'm going to look for print.ANOVA. Okay. Oh, what kind of object do you gave me? You gave me a factor. I'm going to look for print.factor. Okay. Over here, we don't define our things number of observations .mle or n observations something else. We say we call it this way. All right. We say this is a method. N observations we define as a generic, and then we say we define another function as a method for the thing, okay? And it's defined differently. Okay. We can also ask what kind of class it is just by saying is. So we can say what is fit, and it's going to say it's an MLE object. We can say is fit an MLE object, and it's going to say yes. So you can say, you know, is, you know, you can ask that about, you know, a lot of these things, and it will tell you which class it is. So in S4, we have to be a lot more strict. In S3, you could just say the class of this thing, I want to now assign it, say it's class TTT, or I can say it's class this and that. We just say class of this thing, and we just stick in whatever we want to put there, and it would change the class of the object. With S4, we are stricter, and we have to use this formal command called setClass, and we create new objects using the function new. Okay. When you define an S4 class, you're going to need to give it a name, and you're going to give it some slots. And if it needs to, you can use something called contains, which defines how it's going to inherit. So the slots are going to be kind of a list of fields or slots. Okay, and so for example, we can define a person, a class of object. An object of class person, and we will say, you know, a person has a name and has an age. The name is going to be character, and age will be numeric. Okay, you can also use any, which doesn't restrict the input. And then we can create another object and say that object inherits or contains information from another class. Okay, so for example, we can create a person class, and that's going to have the name and the age. And then we're going to create an employee class that inherits from person. So the employee class inherits the slots and methods that are in person, and with employee we'll add an additional slot, boss. Okay, and we create objects using new. Okay, and so here I'm going to create a class. This is the class person, and the class person, the slots are name and age, name being character, age is numeric. Here I'm going to set a new class called employee. The employee, I'm going to skip down to this bottom thing that says contains person, meaning it's going to inherit these slots from person. And to that slots we're going to add one more, and that's going to be boss. And boss, the thing that we put in boss has to be of type person. Okay, so I can't just put in the boss's name. It has to be an object of type person to put into the boss slot here. So here I'm going to define Alice as a person whose name is Alice and age is 40. John is going to be an employee. His name is John. His age is 40. And then the boss is equal to the Alice object. Alice object being of class person. Does that make sense? So let me clear all this out. So that sets class person. We're going to define Alice, and then we'll have John. Okay, and then so Alice is right here, an object of class person. Slot is slot name has Alice. Slot age has 40. Okay, and then John is an object of class employee. In the boss slot, we have Alice, who's 40, and then as far as the slots in John itself, because it's a person, we will have the name John and age 20. If we want to pull any of these pieces of information out, we use the @ sign. Okay? So if I want to get Alice's age, I use Alice @ sign age, and that's going to pull out 40. Okay? I don't use $sign. If I use $sign age, it's going to say the $sign operator is not defined for this. So Alice @ sign name. Okay, and that's kind of one of the key things of S4. Okay, and something happened. Or you can say, you know, what is the slot in Alice in the spot age? Whoops. What did I do? Oh, sorry. Slot Alice age, okay? Or slot John boss, okay? Or we can also do John @ sign boss, and this will return the Alice object. And if we wanted to get Alice's age, we can say, or Alice's name, we can say John @ sign boss @ sign name. Okay? You can have S4 objects inherit from S3 or base types. So in this case, we're going to create a class, an S4 class called ranged numeric. It has two slots, min and max, but it's going to inherit from or contains numeric. Okay. And in this case, to indicate the stuff that it contains, it's going to be in a .data slot. So we're going to create a new ranged numeric, and without saying this is going into any of the slots, we're going to just put this in there, and that's because it's inheriting from numeric. So this is the numeric part that it's inheriting. Into min and into max, we're putting into these things. So let me just show you what this looks like. So we're creating a new class, reference class, or not, new S4 class called ranged numeric, and the new thing is this. So Rn looks like this. It's got two slots, min and max, and as far as the values itself that it's inheriting, the properties it's inheriting coming from the numeric base class, those are in here. And if we do ranged numeric and we do @ sign, we see we've got min and max, I can pull those things out. And .data is the stuff that corresponds to the base type. R is an interactive programming language, so it's possible to create new classes or redefine existing classes at any time. This can be a problem when you're interactively experimenting with R. If you modify a class, you can make sure you also recreate any objects of that class, otherwise you're going to end up with invalid objects. So let me just kind of show you an example of this happening. So if you recall, we have Alice. Alice has a name and has an age. Now I can redefine what a person is. I can say a person should have a name, an age, and a city. All right? And so now Alice still only has a name and an age. She doesn't have a city associated with this. So because the S4 system is much more strict, Alice is no longer a valid person object. It's going to say there's an error in here because there's no slot of the name city. And if I even just ask what is Alice right here, it's going to start listing off what we have, but it's going to say there's no slot for city. So that's going to be a problem here. Okay, are there any questions on this so far? Not yet. All right. We can create new methods and generics. Okay, so we can just take an existing function and turn it into a generic by using the function setGeneric. Okay, so we have the union function. So the union function basically takes two vectors right now. So I could say like 1 through 5, comma 3 through 7. Okay, and it's going to union those, and it's going to say, okay, everything, when I put these together, you're going to get the numbers 1 through 7 here, right? So it puts them all together, but it gets rid of any duplicates there. We can turn this into a generic function and say, I want to make union be able to handle different classes of objects. Right now it only just handles kind of these vectors, atomic vectors, and we can say, well, I want it to be able to handle data frames. So we're going to say turn union into a generic by saying setGeneric, and then we create a method of union specific for data frames. So we say we're going to create a method using setMethod. This is a method that belongs to union, and it applies if the X is a data frame and the Y is a data frame. Right? So we don't have a separate thing called union.dataframe. Okay, in S3 that's how you did it. You'd say like print.dataframe or whatever. So we don't have a union.dataframe. What we have is we say, okay, union, which is a generic, we're going to give it a special method that applies when the X that you're giving it and the Y that you're giving it are both data frames. And if that's the case, this is the function you're going to use. You're going to rbind all the rows and run a unique on that. And that's it. That's how we set methods. We say set method, we give it the name of a generic function, and then we give it the classes for which it applies. And then we give it the function that it'll run. So if I wanted to create a print method for, you know, a tic-tac-toe thing here, I would do something like set method, and it would be for print, and then we would say the class that it's going to apply to will be tic-tac-toe, and then I would say the function is defined as this, right? The function whatever, ttt does blah 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 blah. Okay, and then I put in the function for how it should print. So that's how you set the thing. So instead of doing print.ttt to create the new method, here we would do set method print for ttt. But well, before that you'd have to turn it into a generic function using setGeneric. Okay, if you want to create a new generic from scratch, you would first need to set up a function using setGeneric, and you would have the setGeneric call the function standardGeneric. So this is kind of like for print, there's the use method. For S4, instead of use method, they call it standardGeneric. So you just create this, you create this thing first, which is we're going to create a function called myGeneric, and that's going to be defined as standardGeneric. StandardGeneric for the myGeneric function. Is this okay? You probably don't have to worry about creating your own generics and methods in S4, all right? But you should be aware that this exists. Okay. Are you guys okay with this idea of use method also for S3? I'd say that's a little bit more important than standardGeneric for S4, because this you'll encounter a little bit more often. All right, so now we're going to talk about reference classes, and reference classes are the newest object-oriented system in R. These are very different from S3 and S4 because for reference classes, the methods belong to the objects themselves, not the functions. So in S3 and S4, you have these generic functions and you have methods that belong to the generic functions, and it's up to the generic function to figure out which method to use. With reference classes and a lot of other object-oriented languages, the method belongs to the object. And so when you run the method, it's going to use the method that is inside the object itself. Okay? And then the other big thing is that reference class objects are mutable, meaning that they are modified in place rather than copy on modification. And I'll show you how this works. The way a reference class is programmed in R, or is implemented in R, is that they are an S4 object wrapped around in an environment. Okay? So whenever you create a reference class, it's actually an environment. So an environment has its own little, it's like its own little sandbox with its values and functions that exist inside that environment. Okay. So with reference classes, well, it says reference classes are best used for describing stateful objects, meaning objects that change over time. And so we're going to create a simple one to model a bank account. Okay. To create a reference class object, you use the command setReference class, and then the only thing you really have to give it is a name. Okay, and so here we're going to create account. This is going to be a new reference class of class account, and to create a new account, you do $new. Okay, $new is the method that applies to reference class things, and we say, okay, we're going to create a new account. So we say account $new, and it says, oh, we've created a reference class object of class account. Okay. Right now it's not very useful because we have no fields in the reference class and we have no methods. So we can create fields, and this is kind of like slots in S4, but we just say, okay, these are the fields that we want to keep track of, and we're going to say the field that we want to keep track of is balance, and that's going to be a numeric value. And so we're going to say we're going to create a new object, reference class object, using account $new, and we're going to give the balance field a value of 100, and this is going to be an A. Okay, so let me just show you this. Okay, so here is what an account looks like. We're going to set the balance here, and then here with reference class you use $, and we say, what is the balance? The balance is 100. If I want to say, okay, the balance is now store 200 into the balance of A, that works, and we say, what's the balance in A? It's now 200. Simple enough, right? This part, no surprises. This is the part that is surprising, okay? Here I'm going to do we're going to take A and we're going to store it in B. Okay? I can ask, what is the balance in B? Well, it's 200. That makes sense, right? The balance in A is 200. The balance in B is 200 because I've now stored A into B. But this, watch this. I'm going to store 0 in for the balance in A. Okay, and so I can do, what's the balance in A? 0. What is the balance in B? It is now 0 also, okay? This is very different from what we're used to, right? Because normally we're accustomed to seeing, like, if I have G over here is 200, and I say H is, I'm going to take over here, and I say H is 200, and I'm going to change G to 0, H is still 200, right? Because everything else so far in R is when you store it into something else, it creates a copy of it. And with reference class objects, this references the thing in A, right? So B is referencing A here. So in order to allow for what we used to do, we have a copy method, okay? So we can create C to be a copy of A. We're going to do A $ copy. Okay? So if I ask what is the balance in A, it's 0. I ask what's the balance in C, it's 0. If I do the balance in A is 300, okay? The balance in A is now 300, but the balance in C is 0, okay? Because it's we created a copy, so they're two different things now. So you got to be careful with reference class objects in terms of trying to make new ones. You can't just do the old duplicate thing that we had before. Okay. So now if we want methods, we assign the methods to the reference class. All right. And so here, this is how it looks. We've got the reference class is a count. The field's still the same. It's a balance numeric. Okay. Methods, we're going to give it a list of functions. So we're going to give it 2 functions. So as far as methods go, we've got withdraw is a function and deposit is going to be a function. Now notice here I'm using super assignment. Okay? So this is one of the few times where super assignment is going to be necessary and I recommend it. Okay? Whereas I strongly discourage the use of super assignment to modify things in the global environment. Here you are not modifying things in the global environment because when you create an account, you are creating its own little environment. When you create a reference class object, you're creating, like we create the account A, it exists in its own little environment and it's keeping track of things like the balance. Okay? So inside this environment, inside this sandbox is the balance value. Okay? And inside that environment, because the methods are associated with the reference class itself, are these functions. Okay? And so whenever you run this function, it's going to create an execution environment whose parent environment is that reference class environment. Okay? Does this make sense? So inside our sandbox where the value balance exists also is a function. And if we execute the function, it creates its own execution environment. If we want to have that function update the value in the sandbox for balance, we've got to use the super assignment. Okay, and so all this is doing is saying when you take the balance that exists in the parent environment up here, subtract off x, and update the balance in that parent environment. Okay, the parent environment being the reference class object environment. Same thing with deposit. Okay, we're going to say take the balance, add x to it, and update the balance. So here I'm redefining my reference class for account. We're going to create a new account, A. A has a balance of 100. And I run the deposit function by doing deposit, and I can say something like 50. Okay? And I ran this, and we don't get to see really what happened, okay? Because it doesn't produce an output or anything like that, okay? But if I ask, what is the balance in A, it's now 150. Okay, and A is an environment here, right? So A has, a balance of 150 now. Okay, is this okay? Okay, so this is how we execute it. So we can create other things that reference other reference class objects. Okay, and so we can have something inherit the methods and inherit the fields from another reference class. So here I'm going to create a new class called NoOverdraft. Okay, so here's going to be NoOverdraft. This is going to inherit everything from account. So we say contains account. So NoOverdraft is going to inherit everything from account, and we're going to give it methods, and the methods that we're going to give it will be the withdraw function, and this is a new withdraw function which basically will give you an error if you're trying to withdraw more money than what you have. Okay, and everything else it's inheriting from account. So this time, so NoOverdraft is a new reference class. The only thing that's different is that we've given it the method withdraw. Okay, and so here I've got account John is a new overdraft account. We're going to give it $100. We're going to deposit 50, so we can ask, how much is the balance in John, and we can say try to withdraw 200, and it's going to complain not enough money. Okay, whereas $, the original, this is a regular old account, I can do $, withdraw 300, and it does that, and it can ask what's the balance in A, and it's going to say you have negative $150. Okay, so even though with the NoOverdraft we didn't define the deposit method, because it has inherited it from the account reference class, it works. So over here I didn't define a deposit method, but it inherits the deposit method from the reference class account. Okay, all the reference classes eventually inherit from what we call the environment reference class. Okay, and that one provides methods like copy and call super and all of these other methods that exist and are useful. You can recognize a reference class object because it is an S4 object, and it will say it is also reference class. If you use prior and you use the function OType, it will say reference class as well. Method dispatch for reference class is easy because the methods are associated with the object itself. Okay, so when you call x $f, okay, R is going to look for the method f that exists inside x, and if it doesn't find the method f there, it's going to look in the parent here. Okay, so for example, with account John, oops. So account John, he's got $150 in there, okay, and this has inherited all of the methods from the parent account. So when we ran account John's account $deposit, okay, it originally looks for deposit in the list of methods for class NoOverdraft. It doesn't find deposit in class NoOverdraft's method list, so it goes to class account, which is where NoOverdraft inherited from, and it's going to run it. So I can say deposit $20. Account John now has $20 or balance, or it now has $170. Okay, I can try to withdraw 200, and it says you don't have enough money, and that's because for method dispatch it's going to look for the withdraw method inside account John, okay, or inside the no overdraft class, and it finds it, okay. If we wanted to use the other withdraw, we can say account John, and you notice as soon as I put the $sign there, I've got withdraw, which is the one that comes with no overdraft, but we also have withdraw almost like hashtag account, okay, or pound account, which indicates we want to use the method from the parent class, the account class, not the withdraw method for no overdraft class. So here I could say withdraw 200 and it will execute, and now my balance in John's account is -30. Okay, so we can call request to use the methods from parent things by indicating it as such, but we have to be explicit about it, because as far as method dispatch goes, it's just going to look for that reference class's method list, and only if it doesn't find it, it goes to the parent class. Is that okay? All right, so I guess I'll talk about the midterm exam. Midterm exam will be 1 week from today, next week Friday, and it'll be in class, 45 minutes, handwritten, okay? For most of the problems, I'm going to show you a few lines of code and ask you to write what R will output. So I'm still writing this, and the hardest part for me is figuring out the appropriate length for the test, okay? You guys have only 45 minutes, so I know that's a short amount of time. So I'm trying to figure out, like, I don't know, if it takes me like 15 minutes, 10, 15 minutes or something, I'm hoping that's the right length for the class. So that means some of you will finish in 10 or 15 minutes, okay? And then others of you will take the full 45 minutes, but I'm still hoping that's the right amount of time. As far as the kinds of questions I'll give you, again, I'm going to show you some code, and I'm going to ask you, what will our output here? So I've got x is 0, and we're going to say for I in 1, 2, 3, x is going to be x plus 3, and print out x. Okay, so what is this going to output if I run this?
4, 5, 6.
Okay, well, it's going to, are we a little nervous here? Okay, it's going to output 3 lines, 3, 6, and then 9, right? So, and I would expect at least your output to be on 3 lines. If you put 3, 6, and 9 on the same line, that's technically not correct, because print puts output on its own line here, okay? There aren't any questions on this, right? But okay, yes.
So we should specify every form of it, if we do data frame or as array. So it's gonna be so we need to do every format across.
Well, I would expect the output that you write onto your paper at least look like what R would output. I won't dock you if you leave off bracket 1 bracket, okay? I'm not going to dock you for that. But it should be 3, 6, 9 as separate lines, okay? Because cat would put it into the same thing, but print puts them on separate lines, okay? And if you put them on the same line, this is probably not, this will probably be worth multiple points, and so you'd lose, 1 point out of something, whatever, okay? Some of the code may result in an error, and you would need to indicate that. So if I say x is the letter A, and I say what is x plus 3, and I ask for this, you need to say it's going to return an error. You don't need to say the actual full error thing. I'm not gonna expect you to say memorize that it's going to be non-numeric argument to binary operator. I won't expect that, but I do expect you to say this is going to result in an error. Okay. And errors are different from warnings, right? Warnings mean the code can run and it will produce output, but it will output a warning. Errors mean the code cannot run. Okay. So I do expect that. people always ask, what should I focus on? This is always a very difficult question to answer because, you know, if I don't list it here and it appears on the test, people are going to complain. I would say focus on the content from weeks 1 and 2 the most. As far as weeks 3 and 4, dplyr might make an appearance. I will not put object-oriented stuff on there, okay? And I won't put tidy or rvest on there either, okay? Yeah. What's that? Will I ask you guys to write a program? If I ask you guys to write code, it will be at most 1 or 2 lines, okay? I won't ask you to write a full-length tic-tac-toe computer turn algorithm, okay? If I'm gonna give you a bunch of code, I think it's fair to give you, you know, several lines of code and say, you know, what will this output? What will, you know? I think that's fair, okay? It's easy for me to ask you if you can follow what a thing of code is doing, rather than for you to write out a very long thing. I might ask you to write a line of code, but it'll just be like 1 or 2 lines at most. So, okay, have a good weekend. We'll see you guys on Monday.